Hey everyone, I'm just going to get to work on doing the exercises relating to the tangent function. So um, this one, I'm going to actually do it in reverse order. So I'm going to start off by solving the equations, and I'm going to work back to actually doing the graphs afterwards, because I think that to be able to sketch the graph, it's really important to be able to solve the equations first. Um, so to start off with, we'll solve this equation just here. So we've got 3 tan 2x equals square root of 3. The first step is that, well, we want to make it so it just says tan equals something. So I'm just going to divide both sides by 3. So we get tan of 2x equals root 3 on 3. And you might recognize this as being the rationalized form where we've rationalized the denominator of 1 on root 3. Because if we do both sides of, or both parts of that multiplied by root 3 on root 3, we've got 1 times root 3, which is just root 3, and root 3 times root 3 makes square root of 9, which is just 3. So we've rationalized the denominator. So that's what we're actually going for, okay? It's that same value, the 1 on root 3 is the same as root 3 on 3. And if we know the table of exact values, then we know that tan is going to be equal to root 3 on 3 when the angle is pi on 6. So what I'm going to do then is I'm going to say that our angle there, 2x, must be equal to pi on 6. And we can get the same value again when we go around into the third quadrant. So the equivalent angle in the third quadrant would be pi plus pi on 6, which is 7 pi on 6. So from here, it's just a matter of dividing both sides of the equation by 2. I might actually write down some other solutions here, because this isn't going to be the entire solution. So I'll go back right into the first quadrant again, like after a full revolution. So it'll be 2 pi plus pi on 6, which gives 13 pi on 6. And we'll also have 3 pi plus pi on 6, which would be 19 pi on 6. So then dividing both sides of the equation by 2, we get x equals, so the first one will be pi on 12, the second will be 7 pi on 12, we'll also have 13 pi on 12, and 19 pi on 12. And you can see that these here are all within the original domain of 0 to 2 pi. And, you know, I thought to include these other ones because if x is an element of 0 to 2 pi, then we have 2x, so we could say that 2x is an element of 0 to 4 pi, because we're just doubling everything. So that was why I considered going around the unit circle 2 times rather than just the standard one. Anyway, that is the first example with solving the tangent function equations, and I'll be back with more shortly.